So now let's start visualizing the Titanic dataset. In the previous video, we saw that we can use different types of plots to better understand the data. So in this video, let's see how we can apply our understanding and look at different plots to better understand the Titanic dataset. So we'll go step by step. We'll first look at single variables only. So we'll look at a single continuous variable, and then we'll look at a single categorical variable. In the next video, we'll look at what type of plots can be made for more than one variables. So in order to start visualizing, we'll use different libraries from Python. So Python has a bunch of libraries or packages to visualize data. The most common is the matplotlib library, and we'll use the pyplot package from that, which is typically imported as PLT. Another very well-known package which is quite powerful for visualization is the Seaborn package, which is typically imported as SNS. Now let's look at the single continuous variable and the types of plots we can make for that variable. So remember, we have two continuous numerical variables in our data, the age column and the fair column. So I'll look at the age column and then I'll leave it up to you to analyze the fair column, because it's a straightforward analysis and the program again is provided to you. Now let's say you want to box plot first. So the way you can do that in Python is use the .plot function, and the parameter kind, when you set it equal to box, you get the box plot, and this is where you have selected the age column in the data frame train. Again, that's our training data set. And we've discussed that the box plot is a 5-point summary. So this is the minimum, this is the first quartile, this is the median, this is the third quartile, and that's the maximum. And you can see that these are outliers. Again, one of the usefulness of the box plot is that you can see whether your data has outliers or not. And you can also definitely read the minimum, maximum value, so we can see that the maximum value for the age, if you want to look at outliers, is around 80. The minimum value is quite small, and the median is around 30, 29, 30. And we've seen this when we printed out these values in the summary of the data in the previous videos. So another way you can make the box plot is using Seaborn. So again, that's SNS, and you use the box plot function in SNS, and then that's the name of the column. And so you again choose the column the same way. And so this is the same box plot, but looks a bit more elegant with SNS. And this is just the way you would choose the size of the figure. Now we've looked at other plots also. So the histogram is another plot we looked at. And so now let's say you want to make the histogram for the age column. And so then you would use so this is basic plotting in Python. So the hist function with the color, you can choose the color over here, and the bins parameter, you can choose how many bins you want, and this is the size of the figure, and these are the labels for the two axes. Now you can see that again the histogram gives you the frequency for that variable or data. So you can see that the highest frequency is for ages around 20 to 25. So and the distribution shows that most of the passengers were quite young. There is a peak over here which also shows that there were quite a few children on the Titanic, and these were the outliers we saw in the box plot. So there were a few people who were quite old also, but again most of the passengers were on the younger side. We can also again make the density plot, and you can see from the shape that, as we discussed, the density plot is like a smoothed histogram. And again, the peak is around the younger side. Most of the passengers again were quite young, and this is again the concentration of points. So the concentration of points is is greatest for passengers of age 20 to 25. And again, this peak represents the children that we saw. So we see that there's a concentration. So there were quite a few children again also on the Titanic. Now this is just plotting one variable without any subsetting. Now let's do subsetting. Now if let's say you want to see this continuous numerical variable, the age column, relative to a categorical variable, but still we're still gonna plot a single variable, but we're just gonna see how we can subset that single variable relative to a different column, a categorical column. So survived is obviously is the variable that we're gonna predict in our analysis when we build the machine learning model. So it makes sense to first use that as to subset the age column. So now these are the passengers who survived, and these are the passengers who did not. So, and these are again the labels. So now we get two density plots. The blue is survived, orange is dead. So you can see that most of the children, right? So now this is an interesting observation again, that most of the children survived. And there were so in this range of age 20-25, there were more people who died. Not a big difference, but there were more people who died than survived. So one of the interesting things that you can take out from this plot is that you will see when we do the machine learning analysis that you can actually introduce a new variable, a new column. So that's feature engineering that we'll do based on this observation. So that the whole idea of plotting is that you want to find interesting patterns in your data. And one of the interesting patterns that you see over here is that most of the children survived. So that hints you to it introducing a new feature, which we'll do based on age, and that's the child column. Now you can also subset based on something else, some other categorical variable, and let's say you want to subset based on sex. So now you would get two density plots, one for the male, because we're subsetting based on gender, and then the orange one is for the female. Now one of the things that you can take out from this plot is that most of the children, right, were females, right? So there's a higher concentration for females, but there's and the elder ones, these elderly people were males, but nothing drastic about this plot, just an interesting plot that you can see based on another categorical variable. But our conclusions are mostly focused on the survival column, and because that's going to be the variable we're going to predict in our machine learning analysis. Now, you can also plot the two histogram and the density plots together using the dist plot function in SNS. And you can see, so this is a good way to actually see that the density plot is just a smoothed histogram, right? Now, so this was just a single continuous variable. Let's see that, let's look at a case where you have a single categorical variable. And, you know, for this case, the only plot that, well, a graph that you can make is the count plot, so it's a bar graph that gives you the count or the frequency over here. So survive column is what we're plotting over here. So we have selected that column from our data set. So now you can see that most of the passengers did not survive on the Titanic, and these are the passengers who have survived, right? And we have printed out, if you go back to the previous videos, we have printed out these numbers using the, if you remember, the group by and the value counts function to print out these numbers also. Another categorical variable is passenger class that you can look at. So if you use the count plot for the passenger class, you can see, so these are the three classes, and you can clearly see that most of the passengers are in the in class 3 of the Titanic, and fewer passengers for the other two classes. So these were the two single variables, the two single variables that we visualized in this video. So categorical variable and a continuous variable. Let's see in the next video how we can analyze more than one variables.